The East European high-speed line is no longer something in the realms of myth, but has now become a new reality. Its creation forms a new rail map, not just in France, but also in Europe, aimed at cutting down journey times and making exchanges easier. Thanks to its recognized know-how, ETF has been named as the leader for the first of the 3 lots to be granted to rail companies. Member of a group of companies, ETF has laid almost 242 kilometers of tracks, 418,000 sleepers, over 1 million tons of ballast, and 77 points and crossings. The Auxerre operational base is the starting point for the worksite, with a great number of activities taking place there. It's where materials and equipment are received and stored, where trains are formed, machines are serviced, and where prefabricated sections for laying out on the tracksite are assembled. Sleepers are assembled with the rails, so-called dummy tracks, to form prefabricated sections 17.4 meters long. This assembly requires the use of a gantry that's been specially designed by ETF technical teams. The reliability of the equipment and the way the work is organized make it possible to mass produce and achieve a daily output of 45 prefabricated sections. The project supplied by the client particularly specifies the precise and definitive positioning of the track so as to ensure the smooth running of the TGV. In order to complete these basic sites successfully, it's necessary to be able to measure the position of the track between each operation. A topographical survey service is therefore given the job of installing markers along the length of the railway line. The readings taken through these markers will give the surveyor the exact alignment and lifting measurements. As the work progresses, the controls effected with the aid of these readings will make it possible to fine-tune operations. An innovative new method is being used at the track laying site. The final sleepers are being placed directly onto the track without first resorting to a provisional track. Of the 2 new tracks built, Track 2 is the first to be integrated into the railway line. This elementary worksite brings into play a track laying train made up of wagons, of a hydraulic track laying beam, and a TPM 18 gantry. Traction is ensured by Vossloh BB 61,000 type locomotives, which are capable of pulling very heavy trains. First and foremost, the gantry takes the prefabricated sections from the wagons and moves them close to the beam. Then the hydraulic track laying beam carries them from the train to the railway line. These sections, weighing 12 tons each, are placed with great precision within a margin of 20 millimeters. The following operation consists in joining the sections together with fish plates to enable the train to lay the next sections. After the first 3 pickup passes, ETF uses a CWR train to set down the continuous welded rails on each side of the track, which will subsequently be used to replace the rails on the prefabricated sections. The method used for laying track number 1 is different. The 400-meter continuous welded rails are first unloaded via track 2 with the aid of a bicycle train. Distribution of the sleepers is also carried out from track 2 to track 1. A caterpillar digger fitted with a lifting beam unloads the sleepers. A rail positioner then proceeds to put the continuous welded rails into position. A team is given the job of supervising sleeper spacing and squaring off. The rails are then fixed onto the sleepers by fast clip fastening systems. The position of the track is checked. Finally, the CWRs are welded together. Once the tracks have been placed onto the line, the ETF machine's task is to position the tracks in their final, definitive location within a ±5 mm tolerance. The first gauge consists in raising the track using ballast. A gradually decreasing quantity of ballast, depending on the number of passes, is discharged onto the track. The second stage entails leveling off the track and compacting the ballast under each sleeper. ETF is well equipped with high-performance machines such as a B45 tapping machine and a 108-475 for the points and crossings. These two machines are equipped with the NAO-DAO system. Computer-aided leveling and alignment make it possible to record the state of the track in any area, so as to be able to correct its position subsequently with tamping. The B45 also has the Ballast system. This system makes it possible to level off and align on a strictly uncompromising basis. The third stage entails restoring a correct ballast profile after the tappers have passed over with the aid of a regulator. The last stage simulates the passage of several trains by means of vibrations. This operation checks and ensures that the track is well stabilized. On the first section, ETF has installed almost 77 track points and crossings which make routing forks and crossings possible. Installing the points and crossings can be done with the aid of a gantry or a twin-jib crane. Gantries are generally used at single track junctions because it's impossible to provide adjacent track equipment. In these cases, the points and crossings are pre-mounted and then taken on low lorry loaders. ETF uses twin-jib cranes quite often, track point crossing being set directly into the hole. This operation entails assembling the component parts of the switch crossing at its final location. East European HSL also includes a 3-kilometer stretch of track without any ballast. The geographical site chosen combines several geometrical constraints, such as a bend with a 160mm cant and many track transition curves which are over 200 meters long. A twin-jib crane is used to position the pre-mounted sections onto the concrete slab. These sections consist of special sleepers in order to facilitate future substitution operations. Once the sections have been laid, the track is leveled off with the aid of gauges and laterally displaced by means of struts which are supported by the edges of the concrete slab. The space below the sleepers is concreted in, the slab acting as natural coffering. The concrete is vibrated whilst it's being poured so as to eliminate all the air, and it's then rough cut. ETF has written a new page in its history with the construction of the East European high-speed line. Completion of this new line will certainly be a harbinger of change for rail companies. In fact, putting a satisfactory new method of track laying into practice and experimenting with a ballast-free track will bring the client possible new technical solutions. Pioneer in the field, ETF knew how to commit itself in order to realize its mission and turn the East European high-speed line into a world-renowned success story.